Hi everyone and welcome to this lecture. So here we are going to see how we rebuild the next generation of the population of antibodies. So let's get started. We can see here that we have a lot of little squares ranging from white squares to black squares. And these squares represent the antibodies of a population. The darker the color, the better the affinity, and the lighter the color, the worse the affinity. And a certain population of antibody will select a few of the worst antibodies to be replaced by completely new antibodies, and the remaining antibodies will be replaced by the best antibodies that we choose. We will also choose a few best antibodies to be cloned to replace the whole population of antibodies. So in this example, we have a total of 20 antibodies. 5 will be substituted, 5 will be completely replaced, 15 of them will be replaced by the best ones of the population, of the previous population. So here we have the substitution of these antibodies by completely new ones. And here we have the 3 best antibodies. You can realize the black color, which symbolizes that they are the best antibodies of the population. They will be used to repopulate the whole generation of antibodies. So in the new generation, we have completely new antibodies, and we have the best antibodies being cloned. So here we have 5 completely new antibodies and 15 antibodies comprising clones of the best antibodies of the population. So how do we calculate the cloning rate for each antibody that we select? So here we have the formula. This term right here in black represents the number of clones to be generated for each antibody K in iteration I. This term in red represents the affinity of antibody K in iteration I. N is the number of best selected antibodies. We will determine this number. However, this is usually a small number, like 3 or 5. And here, this whole blue term right here represents the sum of the affinities of all selected antibodies. And CL in green represents the total number of clones to be generated for the antibody population. So let's suppose that we have a population of 20 antibodies. We will select the 3 bests and 3 to be completely substituted. So we have 17 antibodies to be replaced. And here we have the affinity of the 3 antibodies. We are going to select 3 antibodies to be cloned. The affinity of antibody 1 is 80, antibodies 2 is 72, and antibodies 3 is 98. So let's plug and play in this formula. In the red term right here, we have the affinity of the first antibody. Here in blue, we have the sum of the affinities of all the best antibodies. And here in green, we have the total number of clones to be generated. As a result, we have 5.44. Because we cannot have floating point numbers, we will round this number to 5. In the next example, we have the second antibody, which has an affinity of 72. So we'll put 72 here. The sum of the affinities of the antibodies, the total number of antibodies to be cloned, and here we have 4.89. If we round this number, we get 5. So this antibody right here will be cloned 5 times to compose the new population. And finally, the third antibody, let's put in the formula, 98 divided by the sum of the affinities, the total number of antibodies, and as a result we have 6.66, which is 7. So the new population of antibody will be comprised by 3 completely new antibodies, 5 clones of the antibody 1, 5 clones of the antibody 2, and 7 clones of antibody 3, which is the best one. So this is the new population. However, this is not the end. These antibodies will also be hypermutated according to their affinity, and this is what we will see in the next lecture.